Hey everyone, welcome back. In today's video, we're solving a classic LeetCode problem called TwoSum. This is a common interview question, and we're going to go over a few different ways to solve it, from a basic approach to a more optimized one. So let's dive right in. Problem setup. All right, here's the problem. We're given an array of integers and a target number. Our goal is to find two numbers in the array that add up to the target and return their indices. You can't use the same number twice. For example, if the array is 2, 7, 11, 15, and the target is 9, the numbers 2 and 7 add up to 9, so we return their indices, 0, 1. Let's walk through different ways to solve it. Let's kick things off with the simplest approach, brute force. This method is pretty straightforward. We'll compare every pair of numbers in the array to see if their sum equals the target. It's not the most efficient, but it works. What we'll do is create two loops. The first loop goes through each number, and the second loop checks the rest of the numbers. Let's write the code. Okay? Now let's run this and see if it works with our test case. Awesome, it works. We got the correct result, 0, 1. But before we get too excited, let's submit it and see how it performs. As expected, it's not the fastest. This approach gets slower quickly as the array gets bigger because we're checking every possible pair of numbers. That's what we call quadratic time complexity. Now let's speed things up with a more efficient method. Now let's take a look at the hash map approach. This method is way faster. Instead of comparing every pair, we'll use a hash map to keep track of the numbers we've seen as we go through the array. For each number, we'll calculate the complement, the number we need to add up to the target, and check if it's already in our map. If it is, we've found our pair. Let's code this up. Now let's run this and see if it's working properly. Perfect, we got the correct result again. Now let's submit this and see how it performs. Wow, much faster. This solution is running in linear time, which means it only takes one pass through the array. This is a big improvement over the brute force approach because we're not checking every pair. We're just storing numbers in the map and checking if their complement exists. Let's break it down with a quick example. Using the array 2, 7, 11, 15, and a target of 9, we start with 2. The complement is 7, and since 7 isn't in our map, we store 2 with its index. Next, we check 7. The complement is 2, and now we see that 2 is already in the map. So we return the indices, 0, 1. That's how we can find the solution in just one loop. Simple and efficient. Finally, let's check out the sorting and two-pointer approach. In this method, we sort the array first, then use 2 pointers, one starting at the beginning and one at the end. We'll adjust the pointers based on the sum until we find the numbers that add up to the target. Let's code this up. Let's run the code and check if it's working. Nice, it worked. Now, let's submit it and see how it performs. Not bad. This method is solid, especially when the array is already sorted. However, the sorting step adds some overhead, making it slightly slower than the hash map solution. Sorting takes O(n) log n time, which is still decent, but not as fast as the linear time solution we saw earlier. All right, to sum up, brute force approach. It's simple, but gets slower quickly as the input size increases because it checks every pair. Definitely not the best for large arrays. Hash map approach. This is the most efficient solution working in linear time. It's the go-to solution for most unsorted arrays, sorting and 2 pointers. This approach is great when the array is already sorted or can be sorted. It runs in O(n) log n due to the sorting step, making it a good alternative to hash maps. Let me know in the comments if you like this format. Do you prefer more detailed explanations, or was this clear enough? And if you have suggestions for other problems you'd like to see covered, feel free to drop them below. Thanks for watching. If you found this helpful, don't forget to like, share, and subscribe for more coding tips and tutorials. See you in the next video.